So in Science 10, we would have talked about people like, well, give me some people. Who do we talk about? Do you remember in Science 10? It's been a while, I know, but who were some of the famous dudes that came up with theories of what the atom looks like? You know one. You know a couple of them. Come on. Who? Yeah, Bohr. Who else? Those guys. Those are the guys I'm talking about. Aristotle. Yeah. Who? Yeah, Chadwick. Rutherford. J.J. Thomson was another dude. Chadwick was another one, right? So we're not going to go through all that. You already know that. No one cares, right? So, well, I shouldn't say that, but that's on the video now. Awkward. I can edit that out, though, I think. It's not going to. But so we have all these different theories. Now, and that's fine. This is kind of what we currently believe today, okay? And I'm not going to get you to copy all this here because it's probably not all important, but is what we call the quantum mechanic model. And we would have talked about this very briefly in Science 10 as well. Now, I'm going to say this. Yes, we believe the quantum mechanic model. We still use Bohr diagrams. You remember Bohr diagrams? What do you remember about the Bohr diagram? Bunch of circles, right? And we put the protons and neutrons there. Take that. You can't copy now. How's that? You put the protons and neutrons in the middle, yes, and then you put the electrons. How many electrons go in the first energy level again? 2, okay, and then 8, and then another 8, and then we usually stop there because it gets a little complicated, okay? But basically that's kind of how it goes, all right? And we still use Bohr diagrams. We're still going to use Bohr diagrams this year. I'm going to make you draw diagrams of Bohr diagrams, and that's all good. But it's handy for us because we know it's 2, 8, 8, and we can kind of put electrons in their appropriate spot. But what we're saying to you is that in real life, that's not really what's taking place. We can't say, oh, this electron is going to be exactly right here on this energy level because they have random energies. Okay, so yes, probability of finding electrons on, for example, in the third energy level or second energy, probably pretty good. If the atom's big enough, probably pretty good, pretty close. But exactly, no, it's like kind of more like a cloud. If you picture a cloud outside, and in the middle of that cloud is the protons and neutrons, the rest of the cloud is just the electrons. They're all over the place. They usually spin in orbital kind of things. They're just going, buzzing around. They're going super fast. So that's kind of more what we believe today. So that is the quantum mechanic model. I will let you copy this, okay? The most current explanation includes electron cloud. Electrons have certain energy levels, but the exact location cannot be defined. Also, when we talk about atoms, the lowest energy levels, in other words, the ones closest to the nucleus, the electrons closest to the nucleus, those energy levels that are closest to the nucleus, that's where the electrons go first, okay? They always fill up closest to the nucleus. They have a greater probability of holding electrons than the higher energy levels, so the ones farther away from the nucleus. Okay, one of the things about, as with always, this, and please write this down, but the number of protons in the nucleus, of course, is defined as the atomic number, and we find those atomic numbers on the periodic table, right? We'll talk about that in a second once you're done copying that. But the atomic number is also another term for protons, basically. That's the fancy term we give it. Atomic number of proton. We do have to review that stuff. So, and the atomic number, of course, we know is, I'm going to get you some periodic tables, but I'm going to show you also where to go to have an electronic copy as well, of course. But I will get you a periodic table with some formulas on the back and all this stuff that's kind of important, and you guys can have that for quizzes and tests and all that stuff. But I'll show you where to find it online as well, because next year it's always handy to have that for next year. We use the same one as the same one I use in grade 10. I think most people do. Grade 11 and grade 12 as well. It just comes from the data booklet from the Chem 30 Alberta government. So, but remember the atomic number, of course, on your periodic table. On ours up here, they're the red numbers there that are in the top right-ish kind of thing, just because my periodic tables a little different than yours, but they're the ones in the top left, if you remember. So like, for example, hydrogen's atomic number 1, and it's atomic number 1 because it has 1 proton. That's what makes hydrogen hydrogen, right? And if we have 2 protons, of course, then it's not hydrogen anymore, it's helium, yes? And so on and so on. So the atomic number is the number of protons. That's the fancy term for that, okay? So just kind of keep that in mind. Now, in a neutral atom, okay, the number of protons and electrons has to be the same. That's why it's neutral. If you have 10 positives, then you need to have 10 negatives to counteract that, right? Look, this is just simple math, people. Get a calculator out. 10 positives, 10 negatives, 0 is the overall, right? That's what happens when you have 10 positives and 10 negatives. They cancel each other out. That's how we have atoms, okay? Atoms. Those are neutral. There's no charge on, you know, you're walking down the street. Did we talk about, yeah, we talked about, no, that was in this class. You're walking on your way to 7-Eleven today at lunch. You can copy that, by the way. But you're walking on the way to 7-Eleven at lunchtime, and you're like, hey, look, magnesium atom. See, this is what you missed if you're at home. This is like, hey, look, magnesium atom. And I'll explain it for you because this is the funny part. Oh boy, this is tough. This is tough going here. Right? You can't see atoms because they're too small. That's the funny part. Yeah. You're on your way to 7-Eleven at lunch, and you're like, hey, look, it's magnesium atom. Okay, it's got 12 protons and 12 electrons. Okay, it exists by itself. Okay, it's neutral. So let's not forget that. That's an atom. Okay. What do you call it when atoms get charges? That's different, and that's a big misconception sometimes, and I have to explain that over and over again all the time, but that's different, right? What happens when an atom gets a charge? What do we call that? We're going to talk a little bit about that coming up here eventually, but what do we call those? They're not atoms anymore. They're atoms with a charge. Yeah, ions. That's how we get ions, right? And then we're going to talk a little bit about that too. How do you get an ion? You walking down the street and you're just like, hey, look, it's magnesium ion? Probably not. Okay? Because what is a magnesium ion? What do ions have to do? What is the definition of an ion? Let's review. I just want to talk about notes today. Let's talk about, you don't know, somebody else. What is an ion? An atom that has done what? Yep. Gained or lost electrons, right? Well, okay, if you're walking down the street and you see magnesium ion, I'm going to refer to this all year. You're going to get tired of me. I swear. I can't. I swear. You're going to get tired of me because I'm going to be like, okay, so I'm walking down the street and I'm like, hey, look, it's magnesium ion. By the way, does anyone know what the charge of magnesium is? What charge can it form? You've got mail. What charge could it form? 2+. Okay, it's good at losing 2 electrons, and there's a reason for that, and we'll talk about that. But we'll review that. Some of you already know, because it's got two electrons in the outside energy level, and it's looking to get rid of 2 electrons. How do I know that? Because it's in group 2. You know, and maybe you already know that, but we're going to talk about all that again. So it might be boring a little bit at the beginning, but too bad. So magnesium is really good at losing those 2 outside electrons because then it becomes more stable. You know, then it kind of reverts back to, here's magnesium here, number 12. And if you get, where's my attitude adjuster? All right. Perfect, still works. First time I used it all year. Here's magnesium. Well, how am I going to attitude it? No, how's this going to work? I can't know. Yeah. I'll have to go back to throwing markers, I guess, eh? Do you have any teachers that actually, I shouldn't record anymore. Anyone throwing markers? Oh, don't say that out loud. I'm recording. So if you're here, magnesium, right? It's got 2 extra. Look, if it loses one electron, it's more like sodium. If it loses another one, where does it go to? It goes back to kind of neon, doesn't it? Kind of thing. I mean, it's not neon. Don't get me. They're very different, but it's lost those 2 electrons, so now it has 8 in the outside energy level. And we're going to learn something called VSEPR this year, and we're going to learn about why do atoms combine together? because they want to become more stable. They want to become more like Mr. Bachek. Again, you're missing this face at home right now. That's the only thing, right? But that is a good joke. Ask my wife. But you become more stable, right? But, you know, again, if you're walking down the street, I'm going to ask you this at some point, and you're like, hey, look, it's magnesium atoms. That's okay. You could probably say that. But if you're walking down the street, 7-Eleven, and you're like, hey, look, it's magnesium 2+ ions, my next question to you is, that's fine. You can say that, but where do those electrons go? Because it lost electrons. And they just don't lose electrons just because they want to. You know, it's like friends. Sometimes you just can't get rid of them, whether you want to or not. You got to find them some other friends to hang out with. You know, that's part of your job. So, you know, the next question is, well, where did those electrons go? The answer is, well, probably a non-metal would have taken those electrons. And, you know, maybe like chlorine. Chlorine gains some electrons, becomes chloride, yes? Okay, that's fine. You can say that. But atoms just don't lose electrons because they're not happy about it, okay? They have to go somewhere. And we're going to talk about, why do non-metals gain electrons? Why do metals lose electrons? We always tell you before, it's because, you know, they're working together to help each other out. That's actually a lie. Turns out the non-metals are kind of bullies, okay? We'll talk about that. But in a neutral atom, the protons and electrons are the same, okay, in neutral atoms. So that's all we're going to worry about for right now. But that's true, okay? Don't worry about that. We're going to skip that. You know what? Don't worry about that either. I don't. I'm just going to tell you this. The ground state is where all the electrons are in the energy level lowest, closest to the nucleus. Sometimes they can get to the excited state by giving them energy, so they jump up, and then at some point they probably come back down to their ground state, okay? That's how we get sometimes light that's emitted from things like that. I will get you to write this down. This is probably jumping a little bit ahead, but it's true, and probably a big thing. You're going to learn in Chem 20, we are all about valence electrons. We care about valence electrons, and valence electrons are the electrons in the energy level furthest away from the nucleus, okay, by definition. Make sure you know that. That is important. We're going to beat that to death probably. Maybe I should record that, but if you type in chemistry data booklet, okay, Alberta, like I said, you're going to see it's the first one. Usually it's the first one that pops up. It is a PDF, and like I said, I'll put a link in the Google Classroom. I will. What else? I'll put a link in there, and I'll try and I don't remember if I can copy it or not. I think I can, and I'll just put it right in there. Okay, but if you type that into, anytime if you forget your periodic table or you lose it, well, if you lose it, I'll get you another one. But eventually we'll have formulas and stuff like that on there, but this is where this comes from, okay? This is the one we always use, and you have it available. And like I said, if you don't have a phone today, don't worry, or whatever. I think most of you do, but if you don't, that's fine. Maybe tonight we can do that instead or whatever. But if you click on there, okay, you'll get this pretty colored one, right? Alberta Chemistry Data Booklet. And this is the one that this is a booklet. In fact, I have one over there right now, but this is the one you're going to get in Chem 30. We don't give it to you in Chem 20 because this is meant for Chem 30, and it's got a bunch of stuff that doesn't make any sense to you. So we don't give it to you in usually grade 11, but this is a grade 12 booklet that you'll get, okay? And you'll get your own, and you get this on the diploma as well, just so you know, okay? This is the booklet that comes with the test, okay? So if you just scroll up, you know, look, it's beautiful. It's all color coordinated and everything. There's a list of your polyatomic ions, like you remember from last year, I'm sure. The only thing is it's in two parts, so this is the other right-hand side of the periodic table. That's the only thing, okay? And so on. And then it's got a bunch of other stuff that does mean nothing to you right now. There's a few things there. You know, you would have saw this last year, the precipitate chart, basically, kind of thing, right? So that's there, and then a few other fun stuff there, but like I said, that's beside the point, okay? So I'll use this as well right now. If you want to keep your phones out, that's fine. But when we go back to here, for example, we're going to kind of fill in this chart together, okay? So we're talking about neutral atoms for the most part here today. We'll kind of do a little thing at that at the end, and there's a few other examples. And it's looking like might not get to the homework quite yet today anyway, so that's whatever it is and what it is. And by tomorrow, I should have a periodic table for you that you can kind of look on a little easier. Argon, of course, let's find argon. So we're going to go to our periodic table. What number is argon? Sorry, what? 18, okay? So you're going to see that on the second half here. So when I say that, it's right here, yes? Where is it? Right here, 18, okay? So you're going to find argon, and it's atomic number 18, okay? Something called the atomic mass, okay? And it tells you all this stuff up here. Of course, here's some of the common charges and things like that. So in here, we're going to put down, where is it here? 18, okay? The mass number, or the atomic mass, is what we would call, if you look back on the thing, it's what, 39.95, right? Okay. We're going to round that up or down, remember, accordingly. Yes? Does everyone remember that? So we're just going to round it up or down. We're going to talk about why it's 39.95, but it's 40. Okay, 39 point. And if you want to just put, like, if you want to put down 39.95 just for your sake there, that's fine. But we're going to round it up to 40. Okay. Now remember, the atomic number tells you what? From the notes, it tells you, yep, protons. So this one has 18 protons. A symbol that I use for protons is that, P with a positive sign, okay? Because protons are positively charged. So make sure you write that down somewhere. Protons look like that. That's how you're going to label protons. It's easier than saying protons, right? We're going to only do a neutral atom. So how many electrons does it have? It's not your question. It's neutral. 18 positives, 18 negatives, okay? 18 electrons, okay? So this is a neutral atom. If I got 18 positives, I have to have 18 negatives. And then remember, in the nucleus, right, we have what we call neutrons, yes? And that's where the rest of the mass comes from, okay? And when we talk about atoms, if you remember back to Bohr diagrams, well, if we're talking about argon, for example, there's the nucleus. We have 18 protons, and we have something called neutrons, okay, as well. And that's where all the weight of the atom is, right? Remember? So how many neutrons do I have to have in order to get to my mass of 40? And the answer would be, mathematicians, 22, right? So 18 and 22, 18 protons plus neutrons gives me 40 in this case. How many neutrons do I need to have? The answer is 22. 22 and 18 is 40, yes? Okay, so I have 22 neutrons in this particular atom, okay? So 22, okay? Basically, if you want to find them, there's different ways of doing this, but basically if the weight's 40, 18 of the weight is protons. They weigh about 1, okay? Neutrons weigh about 1, so they weigh about the same, roughly. That's a little bit of a lie. They're pretty close, okay? So together, that's where you get the weight of 40, or 39.95 rounded up to 40, yes? Does make sense? Okay? So that's what we're going to fill in somewhere here, right here, I guess. Neutrons, or as I like to call them, are you ready for this? Jimmies. Oh, come on. Toy Story, right? Buzz Lightyear, Jimmy Neutron. Yeah. I know why. I know the kids shows. Don't worry. It's all good. Yeah, I got kids. So 18, and then of course 22 Jimmies, as I like to call them. It's fun to say. Neutrons. Okay. And then atom representation. Don't worry about this too much. Yeah. Yep. Ask on. We're almost, yeah, okay. Yeah. But atom representation, I really don't care about this too much, but just so you know, you'll see different things here. We're going to see argon, and we're going to see something like 1840. That's acceptable, okay? But the other thing I'd say is this. We don't really need to put the 18 there, because remember, 18 is what argon is, right? You can't, if you change it to 17, then it's something different. It becomes what? Chlorine now. So we really don't need the 18 there. Okay, so sometimes you'll see, you don't have to write down all these options, and it's not a big deal. I'm just saying, sometimes you're going to see argon with a 40. That's it, because we know argon has to be number 18. It's 18 protons. That's what makes argon argon. Argon where? Right there. Yeah, I know, Arlo. Yeah. It's funny, okay? Or sometimes you might see, well, argon, why is it here? And the answer is, well, you know, it doesn't really matter. There's different ways of writing it, but the point is this: argon's got 18 protons. We know that, so we don't have to write that down. You might see a number there. That's probably the weight, and there's a reason they tell you that, okay? Because not all, believe it or not, not all argon, not all argons have 40, a weight of 40. Okay, and we'll talk a little bit about that. That comes down to something else. What's that called? Different number of neutrons, right? Remember that term? Ice baby. Dun, dun. No. Oh, come on. That was funny. Isotopes. Remember that? So some atoms have different isotopes, right? Why is it 39.95? We'll discuss that a little bit. Okay. So that's kind of what you're looking at there. Okay. Let's find this one here, and I think we'll be done for today. Yep. Yeah, it's strontium. So we're going to put a little SR there, okay? And then we're going to look on our periodic table. And again, you know, sorry, I apologize. Tomorrow I'll have a periodic table for you. But again, if you go to here, you're going to look around here. Oh, there's 38 right there, right? Strontium. So number 38 is strontium. And of course, it's got a weight, I don't really do strontium a whole lot, 87.62. We're going to round that up or down accordingly, okay, just for easier sake. It has a weight of 87.62 on average, but we'll call it 88, okay, so that kind of matches up. That's all good. How many protons does it have? 38. How many electrons does it have? Okay. How many jimmies does it have? Yeah, put your mask on, go outside though. Mask on. It's got what, 50, yes? Because we have to, 38 and 50 is 88, right? So we have to have 50 here, 50 neutrons, okay? And those are the symbols we're going to use for protons, electrons, neutrons, yes? So you're going to see that quite often here. Atom representation, again, whatever, okay? I'm not too concerned about that. You might see 30, 38, 88, or you might just see an 88 there, okay, to tell you that, hey, this is the one we're specifically talking about. I can almost get, I know for a fact that strontium's got more than one type of isotope. There's probably some 89s or 90s there somewhere, okay? This is on average, this is what it weighs, but that's kind of what we're looking at there. I guess we're not going to get to the homework today. We'll stop there, we'll stop there for today.